very good. So, and then we create two independent variable X and Y. The X is holding all the independent variables and Y is holding the dependent variable. Why we included all the independent variables or the input features? The reason is we want to test with all these input features how well my model performs. Okay, and though we can make out very clearly that Park independent variable and MIC independent variable, these two variables were not correlated well with the price, still we have included these two features with the target variable price. Next step is, yes, we have created two variables X and Y. X and Y, the X is holding all the independent variables, Y is holding only the dependent variable. Now we are doing the training and we need to split the data set into train and test. The training data set and tested data set by default, the split size is 25%. Okay, sorry, the training data set will have 75% data in it, and then test data set will have 25%. Okay, these data were randomly selected from the original data set. Okay, the train and test split is a method that is the one taking the two variables, the independent variable, dependent variable. The X is the one holding all the input features or the independent variables. Y is holding only the dependent variable. So now we are passing these two as an argument, and random state equal to 100. This is the one we used it here to make sure that every time when you execute this script, it should generate the same output, because the train and test split method or the function, it creates it randomly sample 75% of the data for training and 25% data for test data set. Every time when you run this, the train and test data should not change it. Okay, it should remain the same. For that reason, random state equal 100 we used it. And then this is where we fitted the model. We trained the model. I've initialized the linear regression model here. And then using the fit method, we have passed the independent variables of my training data set, dependent variable of my training data set. And so with that, my model got trained and we did not get any error. And next line, model dot. Now my linear regression model is nothing but model dot coef. You can give any name, but here I have given model. Okay, coef. This gives you the coefficient or the beta coefficients. Okay, the slope for all the independent variables, the size, UDS, Park, MISC. When we discussed about a simple linear regression, we discussed about only one slope, right? Because in the simple linear regression, we have used only one independent variable. Yes, Soundarya, you are correct. Shri, you are correct. And Swarna, okay, Swarna, yes, Swarna, I'm here to start. Wait, okay. Okay, so here, in this case, we have trained the model. Okay, and each and every independent variable have a corresponding slope value for it. Okay, and then we have intercept, model dot intercept underscore. This is the intercept value given. These are the beta coefficients. Okay, this intercept value remains constant, whereas this beta value, the coefficient value or the slope for each independent variable, are differing. Okay, it is not constant. These values are estimated by the model automatically. Hence, we don't have the headache of computing it manually. Okay. Next one, yeah. Now we are able to see the intercept and coefficient. Next step is we want to apply the trained model on the test data set. So model dot predict. You need to use the predict method or the function to apply it on the trained model on the unseen data. Now the predict function will hold all the predicted values for the unseen data, which is nothing but the test data set. Okay, by typing pred, and if you click on run, you can see the predicted estimated housing price for the unseen data. Okay, next one is how do we, okay, I have trained the model and I applied the trained model on the unseen data to make a prediction. Next step is how do I make sure that my model predicted values accurate. So these are the predicted values. Fine. How accurate are they? How well my model is doing it? That is when we have something called root mean squared error. it is a function, okay, or the method that is available as per the metrics. Okay, metrics class. Here, this is the method that is available. You need to pass the actual and then predicted value. This is your actual housing price and predicted housing price. What is the predicted housing price? This is the one, right? So pred, and then the y test is the one holding the test data split, 25% of the test data related to dependent variable, okay, the housing price. When you pass this, and if you take square root on this one, it gives me this much error. This is root mean squared error. Okay, and the next one is y train pred one. This is on the test data set. If I wanted to know the root mean squared error for the training data set, instead of passing the test data dependent variable, we are passing the training data set dependent variable, and then the predicted value of my trained model. Okay, so this is the one I passed it, and we can see 1.58. So now the training root mean square error and test root square error, it should be somewhat close by, but there is a slight difference here. That probably what we'll do is, in that kind of situation, we can knock out these two variables which are not at all helpful in terms of correlating with my target variable price. Okay, so again, you need to create the model, recreate the model, include only the two variables. Okay, and then you just check the error. But we tested it in the last session. Still, we did not see much difference with respect to the difference. Okay. And also, we discussed about the assumptions. Linearity. What is the linearity? Each independent variable should be correlated well with your dependent variable. And then the residential, right? So the independence. The residents should be independent of each other. And almost the variance of residuals or errors should be constant across all levels of the independent variables. Okay, we discussed homoscedasticity also, and normality of residual. The residual should be approximately normally distributed. No or little multicollinear. There should not be any multicollinearity. Okay, what is multicollinearity? All of you type it in the chat window. So this one can help us to understand how ready are you in terms of clearing the interview. So you need to clear the interview. You need to talk to the customer. Yes, Deepa, you're correct. So multicollinearity. Okay, what is multicollinearity? Yes, there should not be any correlation exist between two independent variables. Deepti, you are correct. Sai Sudha, you are correct. And Saundarya and Swarna and Sara, very good. Ramya, I guess all of you are up to the speed, right? You are preparing well. See, those people, Saundarya and Deepti, all these people, all these, all these students are working professionals. Though they are working professionals, still they are able to keep themselves up to date, and they are working in IT industry. Okay. So okay, guys. Okay, next one is C. These are the 5 different types of assumptions that needs to be met apart from the error. So lesser the error, the better the model accuracy. For example, somebody tells you, hey, to paint the whole apartment, it will cost you 15 lakhs. How accurate the value which they give? Is it really 15 lakhs or 14 lakhs or 16 lakhs or 18 lakhs? So, right, so somebody predicts and tells, hey, for this, the estimated painting cost is 15 lakhs, sorry, 15 lakhs, okay. Now the next question is how accurate this one is. There will be variation. There will be variation. Variation can be there, but it should not be too much, okay. If somebody asks you, hey, painting cost is 15 lakhs, and the variation is anywhere between 1 lakh to 25 lakhs, do you accept? Do you agree that? If they say anywhere between 14 to 18 lakhs or 17 lakhs, then it makes sense. Okay, the range. Okay, okay, fine. And after you painted your apartment, you compare the actual price with the estimated price. If both of them are somewhat closer, then the prediction accuracy was good, right? In case the difference is too much, we'll say, hey, you did not give the proper estimation. That is the reason why so many confusions happen. Okay, so with the root mean squared error, we are able to find out what is the error, right? If the error is lesser, better the accuracy. The same. That's why I use that analogy. the estimated painting price, and then after painting the house, see, before painting your house, they'll give you the estimation. So something like 15 lakhs. 15 lakhs. And after painting that, right? Listen, after painting that, it comes around 15.5 lakhs. So very less difference, right? There is a prediction. The estimation, with respect to the estimation, it is not too much of variation. Slight variation is it? It's good. Lesser the error, lesser the variation, it is good. Keep that in mind. This is the important thing, guys. Don't think, simply you will get a job. Okay. Next one is I have used the another package. These are the package I used it. We have something called smf.ols, ordinary squares, and here we fitted the model with size and UDS only because these two independent variables, only these two independent variables are correlating well with my price, right? And the output of this one gets stored in LM, and lm.summary function gives you the detailed information. Here you can see what is the independent variable used it, what is the model, ordinary least square, ordinary least square. This is called ordinary least square. Least squares. The method is least squares. Look here itself, he has given least squares. In which date we ran a model and what time and number of objects, how many number of records we used it, how much error we got it, and then what is the degrees of freedom. So number of columns, okay, 2, and R squared. So this is another metric apart from the root mean squared error. The R squared and adjusted R squared is very much used to measure the linear regression model performance. If the R squared value or the adjusted R squared value is closer to 1, it means your model accuracy is good. Here it is 0.90. It is somewhat closer to 1. Good. Okay. Now the question, what is the difference between R squared and adjusted R squared? R squared explains how much variability explained by model. If I include two independent variable, how much variability explained by model? Okay. So 90% of variability, my model was able to explain it well. And adjusted R squared is 0.8. So there is a slight difference between these two values. And in general, the R squared value is more than the adjusted R squared value. The adjusted R squared is the one we use it to measure the model's performance. Adjusted R squared is the one we use. See, it's something like we use the thermometer to measure our body temperature, right? If our body temperature is how much? 0.94 or 0.98, right? 0.98, then we are good. If our temperature is 0.99, 100, that means we are not good. So similarly, when you take a model using the adjusted R squared, we are going to measure how well my model performing well. Yes, Soundarya. See, then why do we need to use root mean square? That is the question from Soundarya. See, this one tells us how well my model explain, or the proportion of variation explained. What is the proportion of variation explained by my model? That is 0.90. Okay. What is the proportion of variation explained by model? That is the one given by my adjusted R squared. Whereas the root mean squared error gives us the the error. Okay. Squared error. Okay. Hope you remember we discussed about error. What is error? What is error, guys? What is error or residuals? Both of them are seen. Yes, Soundarya says the difference between actual and predicted. Yes, that is what error. Actual and predicted is error. And what about the other one? Why when I ask questions, people are dropping. Fatima dropped. Why she dropped? Okay, and yeah, so other person, yeah, actual and predicted. The difference between actual and predicted is error, and what else? Who else? This is what error, right? If you square the error, that is called your sum of squared error. Okay, and yes, Prashant, you are correct. Difference between actual and predicted. The same should come from everyone, guys. All of you, please be alert. And yeah, so that is the one it tells us. Okay, so okay. Now the question is, In addition to root mean square error, we use adjusted R squared also in the case of multiple linear regression. What is multiple linear regression? When you use more than one independent variable, we call that as a multiple linear regression. So in this case, the adjusted R squared 0.894. It's somewhat closer to 0.90, which is closer to 1, hence the model is accuracy is good, we can say. But guys, remember one thing very clearly: when you work with the real temporal, the customers are very tough guys, very tough nut to crack. They say still, why 0.90? Why can't you make it to 0.9949698? 0.98. Can't you make it 0.98? Okay, first of all, what the difference between R squared and adjusted R squared? So both of them are a metric using which we can measure the model's accuracy in addition to root mean squared error and all. But the difference is the adjusted R squared penalizes the features, that doesn't contribute to the model prediction. Okay. So what do you mean by penalizing the features that are not helpful in predicting my housing price? You remember the park and MISC? Those two features, input features, were not at all helpful in terms of predicting my outcome variable price. But what happens is, in the case of R squared, when you add more number of features, size plus UDS plus park plus MIS, just because you have more number of features, it blindly increases this value. It's something like in a project, you have, 10 people are there. You are the project manager, and people above you asking you how many people are required to complete the project. And if you tell them, I need 10 people or I need 8 people, they say, okay, 8 people, what we do is we'll give you 10 people. Complete it in 10 days time. Do you think having more number of headcount will help you to complete the task on time? Yes. No, right? Yeah. Correct, Soundarya. Soundarya and Deepthi are correct. Yeah. More number of people doesn't mean more number of productivity, which means, see, let's say 10 people are there in a project. That doesn't mean all the people are experienced people or they are smart people, right? Let's say out of 10 people, let's say you are a manager, out of 10 people, only 2 people are smart, the rest of them are dumb guys. What will happen? Your project will be in deep trouble, right? A lot of escalation, no sleep, heart attack, stroke, everything will happen, right? So if all the people are at least 60%, 70% of the team members are smart enough, and then you can pull the project through, right? Otherwise, what will happen? Things will go. Just because somebody gives you more number of people, what happens? According to the management, they'll say, hey, I've given more number of people. The productivity should be more. Simply they go by the head count. Who? Management. But as a project manager, you are going to penalize. Of the 10 people, you gave it 10 people, but only 3 people have head. Rest of them have kidney, right? They are not useful. Hence, I'm going to penalize all the useless guys. And with the useful guys, this is the one I can say. You understood this analogy, or able to understand what is the difference between R squared and adjusted R squared? As you add more number of independent variables, it blindly increases the value. Whereas adjusted R squared, it is not blindly going to increase or inflate the R squared value. Instead, it will penalize the features that are not helpful in predicting my dependent variable. Okay. Next one is the F statistics. So it gives us the F statistic. And also along with that, it gives me the probability of F statistics. So is this, this is your P value. So is this P is less than alpha? Is this correct? So okay, first of all, what this P value is nothing but, this is a probability of statistics, the P value, right? So the E minus 72, which means you need to prefix with dot 71 zeros before it, which is closer to 0. It's nothing but 0. Hence, the P value is less than alpha. Alpha is 0.05. Okay, since p-value is less than alpha, we are going to reject the null hypothesis. What do you mean by reject the null hypothesis? This p-value tells us overall how well my model performs with the given independent variables. Okay, so here the here the null hypothesis, whatever the independent variables that we are using it are not helpful in predicting my target variable. Since the p-value is less than alpha, we are rejecting the null hypothesis. We are going to control whatever the independent variables that we used it here is contributing in terms of explaining the variability in my outcome variable, which is nothing but my housing price. It gives us an overall idea, okay, right? But it will not give you feature-wise whether it is statistically significant or not. It will not give, yeah, it will give you in the overall model, I know how well the model performs with the given independent variables. It's something like if somebody tells you your temperature is, body temperature is normal, that doesn't mean you are normal, isn't it? The body temperature is normal, but still you have a stroke, right? You are not able to just because, but temperature tells us, okay, this guy is not having any fever, okay, fever. That's all. Okay, maybe pulse rate and heart rate tells us okay, right? But your blood pressure is not good. It's too high. Okay, something like that. Okay. So in this case, the the F statistics or the p-value, the p-value for the F statistics tells us whether the given overall the model is good or not. Heart rate is good, temperature is good, maybe blood pressure is also good, or sugar is also good, normal. So overall, this guy is good. But how well these things are contributing? Okay, his blood pressure is normal and his heart rate is normal, but still his cholesterol level is very high. That is another parameter, right? This one will give you the overall idea about the model. It will not give you feature wise how each one contributes in. Okay, log likelihood minus 288. Right, so this one, yeah, log likelihood. What is log likelihood? Statistics student. This I will discuss it. Okay, I will discuss it as part of the logistic regression. At this moment, let's not worry about this. So next one is the AIC and BIC. What is AIC and BIC? AIC stands for archaic information criteria. Only the terms are little bit difficult to pronounce. Otherwise, it's all very simple concept. Am I audible to you all? There is a problem here, guys. Sorry. Oh my God. Rajesh, you don't operate that. I will give me a control, ma. Give me control to my system. Rajesh, you there? Why you enable video? Don't enable video, okay? Give a control to me. I will take over. 1 second, guys. I will just okay, so now the point is, thanks for giving me the control. Here, if you see here, right, we have got some amount of idea. So AIC stands for Akai Information Criteria, and BIC stands for Bayesian Information Criteria. So what is the difference? Archaic. Rajesh, ப்ளீஸ் நீங்க வெளியில லாக் அவுட் ஆயிடுங்கம்மா, நான் பார்த்துக்கிறேன். Please don't enable video. Bayesian information criteria. Archaic information criteria. It gives you some number, and Bayesian, both of them are somewhat similar. See, for these two, so when you include two independent variables, the AS is like this. or BIC is like this. But when you fit with different combination, for example, size plus UDS plus par, with the three independent variables, what is the ASC and BSC? And for example, you are using size plus UDS plus Spark plus MI. So all the four independent variables, what is the ASC? And you are going to use size plus UDS, what is the ASC? By comparing all the three models, first model involves all the four independent variables. You need to note down the ASC and BIC. The second model, you have some size plus UDS. Okay, for this, so compared to the two model, for this model, for this set of independent variables, the ASC is lesser the ASC, better the model. Okay. So these two independent variables, this is another way of doing the feature selection. Okay. So the lesser the ASC, better BIC and ASC, the better the model, the better the features are performing. Okay. Or lesser the AEC value, that is the best model. Okay, that is another way of doing the model selection. They'll ask you in the interview, how do you do model selection? We have something called AEC, BIC value. So with the different set of input features, we tried fitting the model, but for specific features, for example, size and UDS, the AEC value was less. Hence, we decided this is the best fit model. Okay. So this is how we can do the model selection. Okay, the lowest Bayesian information criteria value. It is the benefit for best fit for the model. Okay, and that is what we decide. So AIC, BIC now interested simply. Okay, don't get into too much of detail. What exactly a kike information gradient. So these are the two metric. When you include two features, okay, when you include three, sometimes when you include three features, this value will reduce. It doesn't mean when you increase more number of features, this value will increase. Okay. If the variables are really helpful in predicting the target variable, this one will show the lesser value. Lesser the ASC, BSC, that means that is the best fit model. Okay. Next one is the intercept. This is the coefficient value for the intercept. This is the size and UDS. This is the coefficient value for size and UDS. Okay. And these are the error and the t statistic and the p values greater than the t statistic value 0. And this will give you the range of values. Apart from this, we have omnibus test and probability of one. This one we'll discuss it later. I don't want to discuss now. You will be overwhelmed. Okay. Next one, yeah, these are the this is how you can interpret the model. But remember, guys, you need to know this one very clearly. What is suggestion? There is not much difference. AAC and BAC, there is not much difference. More or less same only. Okay. Then why they've given two different things? So that is the metric. You just keep that in mind. There are certain things. Don't reason it out too much. Okay, literally go by the numbers. Okay. So at this moment, how do I do the model selection? This one way of doing the model selection, AAC and BSC will give you the value. So lesser the value. For example, if I put two values, two columns, the value is less, then for example, if I put four columns, size plus UDS plus MISC plus par, with the AAC values, for example, if it is more, not necessarily always more, let's say hypothetically it is more, that means those two independent values are not helpful. Similarly, try with 2. Now with the 2, you can see by 3.3. Okay. Or if you use Spark plus MISC, the AAC value will be more. So that is not the best fit model. And size plus UDS, what is the AAC? Lesser the AAC, BAC, that is the best fit model. Okay. Got it? That's all. Okay. And this one, you don't worry too much. What is the difference between AAC, BAC? Both of them are same. These two metrics are helpful to do the model selection. Okay. What is that? Your question? Oh, yeah. So that I will explain. See here, the question is, so what is this 0.469 tells us? That is the question from Deepthi. Okay. All results will give AS and BAC. Why? All results, yes. Everything will give you the metrics. See, adjusted R squared, how it gives the same way, it gives you that one. That is the reason why I told you it depends on the number of independent variables. Okay. If you have 2 independent variables, 3 independent variables, It doesn't mean if you have three more independent variables, the value will be less. Or if you have less number of independent variables, so what it does is it checks which variables are actually, like I said, the simple example, right? 10 பேர் இருக்கிற டீம்ல யார் வந்து ஸ்மார்ட்டா இருக்கிறான், மீதி எல்லாம் எவன் தத்தியா இருக்கிறான் இல்லையா, அதை வந்து ஏஐசி கண்டுபிடிச்சி சொல்லிடும். அவ்வளவுதான். அதாவது கம்மியா இருந்ததுன்னா அதுக்குன்னு 10 பேர் இருக்கிற டீம்ல 2 பேர் தான் இருக்கிறான்னா ஏஐசி கம்மின்னு வராது. பட் அந்த 10 பேர்ல 2 பேர் தான் ஸ்மார்ட்டா இருக்கான், ப்ராஜெக்ட் சக்சஸ்ஃபுல் அவன் தான் காரணமா இருக்கிறான்னா, அப்ப என்ன ஆகும், ஏஐசி வேல்யூ கம்மியா காமிக்கும். இப்போ 10 பேர்ல வந்து ஃபார் எக்ஸாம்பிள் 10 பேர்ல 5 பேர் நல்லா ஸ்மார்ட்டா இருக்கிறாங்க, 5 பேர் தான் சரியில்லை அப்படின்னா, அந்த 5 பேர் வந்து நல்லா இருக்கிறாங்கன்னா அதுக்கு தகுந்த மாதிரி ஏசி கம்மி பண்ணி காமிக்கும். புரிஞ்சுதா? அதுதான் ஏஐசி பிஎஸ்சி ரெண்டும் ஒன்று தான். ஓகே, there is not much difference between these two. பட் இன்னும் டீப்பா பேசினா கன்ஃபியூஷன் ஆயிடுவீங்க. இப்போதைக்கு இது போதும். Okay, next one is how to interpret the model's output here. Here we can see that 0.0469 for size and UDS 0.17. Right? So what is it? How do you interpret this one? I have explained to you as part of simple linear regression. The same principle is applicable here. Right? So what does this? There's out of our example I gave you now. Yeah. No, it is not 0.05. This is not p-value, ma. This is coefficient. This is the slope value. The size is the slope and UDS is also another slope. Here it is not even a value, it gives us the slope. Okay. For example, what is your dependent variable? Price. The regression is y equal to beta naught plus beta 1x, right? Since we have more than one independent variable, x1, x2 will come. So beta naught, what is the intercept? 0.3.0074 plus what is your beta 1? This is the one, 0.0469 into 400 square feet plus what is, sorry, this is beta 2. Beta 2 is your UDS, 0.1797 into x2 is 200 square feet, okay? So if you add all the things, whatever you get, that is what the estimated housing price. Y hat, they call it as a Y hat. Y hat means estimated housing price. Dipti, I will come back to you, okay? That we'll see. So Soundarya, hope you understood, right? So which means here, these are the coefficient values, okay? The slope, the beta 1 and beta 2. What is beta 1? 0.0469. Beta 2 is your ஒவ்வொரு இண்டிபெண்டன்ட் வேரியபிளுக்கும் ஒரு ஸ்லோப் இருக்கும், அதை மறந்துடாதீங்க. Slope will differ from one independent variable, another independent variable, whereas intercept is common. Okay. So what does this value do? For example, a 1 unit increase in the size or a 1 unit increase in the square feet will have 0.4 times increase in your housing price by holding all the other variables constant. மற்ற வேரியபிள்லாம் கான்ஸ்டன்ட்டாக வச்சுக்கிட்டு இதை மட்டும் நம்ம எடுத்தோம்னா நம்ம ஹவுசிங் ப்ரைஸ் வந்து 0.04 டைம்ஸ் வந்து இன்க்ரீஸ் ஆகும், ஒரு ஸ்கொயர் ஃபீட் இன்க்ரீஸ் ஆகும். ரிமெம்பர், out of where I gave you the example, right? If you for every 1 kilometer increase in the distance, your auto fare will increase by 5 times or 4 times. The 4 times is nothing but your slope, right? Same way, here the slope for the size is 0.0469. So 0.0469 அப்படியே இங்க காப்பி பண்ணி போட்டுக்கிறோம், இது அப்படியே தூக்கி இங்க போட்டுக்கிறோம். பட் நம்ம டேட்டா செட்ல ஃபர்ஸ்ட் ரெக்கார்டு 400 ஸ்கொயர் ஃபீட் இருக்கும், அதோட இதை மல்டிப்ளை பண்ணிக்கும். அதே மாதிரி இந்த யூடிஎஸ்க்கு வந்து என்ன இருக்கோ அதை எடுத்துக்கும். ஒவ்வொரு ரெக்கார்டுக்கும் இந்த ஸ்லோப் வந்து ஒவ்வொரு ரெக்கார்டு வேல்யூ மல்டிப்ளை பண்ணிக்கும். புரிஞ்சுதா? டோன்ட் ஃபர்கெட் திஸ். ஃபார் எக்ஸாம்பிள் செகண்ட் ரெக்கார்டில் வந்து 500 ஸ்கொயர் ஃபீட் இருக்கு, அப்புறம் வந்து அதே செகண்ட் ரெக்கார்ட்லேயே யூடிஎஸ்க்கு வந்து 200 ஸ்கொயர் ஃபீட் இருக்கு. இந்த வேல்யூவோட கரஸ்பாண்டிங் ஸ்லோப் வில் கெட் multiplied. Okay. So similarly, the 0.17 is for 1 unit increase in undivided share, the housing price will increase by 0.17 cents or dollar அப்படி சொல்லலாம். Okay, 0.17 cents by holding all the other variables constant. மற்ற வேரியபிள்லாம் வந்து கான்ஸ்டண்டா வச்சுக்கிட்டு இதை மட்டும் நாம கணக்குல எடுத்துக்கிட்டா ஹவுசிங் பிரைஸ் வந்து 0.17 டைம் இன்க்ரீஸ் ஆகும். மற்ற வேரியபிள்லாம் கான்ஸ்டண்டா வச்சுக்கணும் அந்த டைம்ல. அதுதான் இதனுடைய மீனிங். புரிஞ்சுதா? திஸ் ஹவ் யூ நீட் டு இன்டர்பிரட் this one. Okay, so we were asking about AIC, BIC, right? So AIC, BIC, like I said, the AIC and BIC basically it penalizes the model complexity. Okay, but the difference is it is the AIC is much more stringent or so much less stringent than your BIC. BIC வந்து ரொம்ப ஸ்ட்ரிக்டா இருக்கும், பின்ன ப்ராப்பரா வந்து penalize பண்ணும். Okay, so basically the BIC, what it does is it includes a term that is proportional to the logarithm of the number of the data points. Abdina, which means the BIC is more likely to favor simpler models, especially when the sample size is small. Whereas in the case of AIC, what it does, it uses a penalty term that increase with the number of parameters in the model, but it is little less severe than the penalty used by BIC. See, simple rule of thumb வந்து என்னன்னா, இந்த interview when they ask you, just tell them AIC and BIC is more or less same, but BIC is much more stringent. ரொம்ப ஸ்ட்ரிக்டா இருப்பாரு, இவரை விட இவர் ரொம்ப ஸ்ட்ரிக்டா இருப்பாரு, அவ்வளவுதான். But AIC is enough to determine the best model. Okay, model selection க்கு வந்து அது better. எந்த மாடல் பெஸ்ட், எந்த மாடல் பெஸ்ட் என்ன அர்த்தம்? ஒரு மாடல்ல 2 காலம் வைக்கலாமா இன்புட் ஃபீச்சர்ஸ், இல்ல 3 ஃபீச்சர்ஸ் வைக்கலாமா, இல்ல 4 ஃபீச்சர்ஸ் வைக்கலாமா? எந்த ஃபீச்சர் காம்பினேஷன் வச்சா அந்த மாடலோட ஏசி கம்மி ஆகுது, அந்த மாடல் தான் பெஸ்ட் மாடல். புரிஞ்சுதா? நம்ம டீம்ல 5 பேர் இருக்காங்க, 5 பேர்ல யாரு நல்லா வேலை பண்றாங்களோ அவங்களை தேர்ந்தெடுத்து அவங்களுக்கு வந்து நம்ம வந்து என்கரேஜ் பண்ணோம்னா அவங்க என்ன பண்ணுவாங்க, டீமோடைய சக்சஸ்க்கு வந்து ரொம்ப உறுதுணையா இருப்பாங்க இல்லையா? அந்த 3 பேரை வந்து நம்ம எடுக்கணும், மீதி 2 பேரை நம்ம எடுத்துடணும், அவ்வளவுதான். பிகாஸ் அவங்களால ஒரு யூஸும் இல்லை, அதனால நம்ம எடுத்துடணும். அப்படி ஞாபகம் வச்சுக்கோங்க, சரியா? So now you understood, right? So the AAC is BAC used for model selection. That's all. But BAC is more stringent than the AAC. But BAC it penalizes more complex models more heavily than your AAC. Okay, but more or less these two values are somewhat close by now. You can use any one of them. That is okay. If they ask you what does it do, these two, it penalizes the model complexity. Okay, so now you understood. But here the advantage of the OLS function, which is available as SMF package, standard model formula, it gives us a detailed summary, right? It gives us a detailed summary. Okay, with this we are able to understand how to interpret the model. Okay, any questions? What is the Deepthi asked question? Okay, how do I know that? Yeah, the assumption, you see, in RC, apart from adjusted R squared, that is the metric, you need to use it in the case of linear regression model. Okay, but the adjusted R squared also penalizes the model. Okay, what is the difference in AAC and adjusted R squared? This is the question from Deepthi, right? So you can use either the adjusted R squared or you can use AAC. Okay, see, if you use the different combination of features, obviously you will get different values for R squared and adjusted R squared and AAC, right? So for a specific combination, if you see higher the R squared, it is better, lesser the AAC, better. Okay, அப்படிதான் இருக்கும். Okay, next question is what is Durbin-Watson? Please explain. Okay, Durbin-Watson is a statistics. Okay, it tells us are there any autocorrelation exists in the residuals. Okay, so if the values are closer to 2, tells us there are no significant autocorrelation. What do you mean by autocorrelation? This is one of the assumptions, right? What is autocorrelation? How many of you remember it? The linear regression assumption. The Durbin-Watson test is helpful to check are there any correlation exists between one error to another error. Okay, that is what your Durbin or Watson test tells us. And the other question is what is omnibus, probability of omnibus? See, it is something like a p-value. Okay, see, the omnibus test, that is for normality of the residuals, whether the residuals are normal or not. Okay, if the significant results suggest the residuals are not normally distributed. Okay, the values are too high, that means the residuals are not normally distributed. And with the p-value, see, followed by the omnibus, we have something probability omnibus. This one tells us how well the residuals are normally distributed. Since the p-value is less than 0.05, the alpha, right? So we are rejecting the null hypothesis. The null hypothesis in this case, the residuals are not normally distributed. Since we are rejecting it, we are going to conclude that the residuals are normally distributed. Okay, with this we can tell. Next one is okay. Okay, what is skewness and kurtosis? Okay, here this is related to residuals. See, these things are related to error. Residuals are nothing but errors. Okay, the skew and kurtosis. This gives us information about the skewness and kurtosis of the result. What is skewness and kurtosis? How many of you remember it? We discussed as part of descriptive statistics. What is skew and what is kurtosis? The peak of the tail is nothing but kurtosis, right? The peak of the tail is nothing but kurtosis. Skewness is something like a right skewed and right. So when you plot the residuals, and the peak is too high, right? And if the skewness is something like that, okay, so then in that case, it gives us an idea about the residuals. Okay, that's all. Okay, not much information, but omnibus test tells us the normality of the residuals. Okay, that's all. Okay, what else here you need to know here? That's all. Okay, so if you know, okay, what is DF tells us the degrees of freedom associated with the model 2. So overall we have 3, right? So 3 minus 1 is 2. 2 in this model we have used the degrees of freedom is 2. That is what it tells us. So the omnibus test tells us what? This is very interesting name, right? Omnibus test. What is this omnibus test tells us? The p-value. You need to look at the p-value associated with the omnibus test. It tells us whether the residuals are normally distributed. You know what is residuals? It's nothing but error. The difference between actual and the predicted value, that is what is error. When you plot all the errors for all the records in a data set, it should normally distribute it. Okay. If the p-values, omnibus test helps us to understand how well the residuals are normally distributed, whether the residuals are normally distributed. Since the p-value is less than alpha, we are rejecting the alternative hypothesis. It is the residuals are normally distributed. Okay, and skewness and kurtosis talks about, it gives us information about your residuals. When you plot the errors, what is the peakedness of the error and what is the skewness of the error. Okay. And next one is Durbin-Watson test. What is Durbin-Watson test? Just now I told you. Autocorrelation. There should not be any correlation between one error to another error, one residual to another error. Okay, that is what it tells us. And again, Jarki-Berra. So Jarki-Berra p-value, right? So the p-value is less than alpha. Okay, with this, also we can say that the model, how well, here the Durbin-Watson tells us autocorrelation. Even This also tells us the same thing, okay? The autocorrelation, okay? Are there any error, residuals? It's all related to your residuals, okay? The p-values, less than alpha. In this case, so it tells us basically whether it is the residuals violate the assumption of normality. Okay, even the Jarki-Berra also tells the same thing. Durbin-Watson, Jarki-Berra probability p-value, right? So minus 30. Since this is less than alpha, we are rejecting the null hypothesis. We are going to say the residuals are normal. Okay, it is not violating the assumption of normality. Durbin-Watson test that is related to your autocorrelation. And omnibus is also related to your normality, residual normality. So probability of omnibus and probability of Jarki-Berra, both of them are somewhat similar only. What is COND number? Okay, so this is kind of a condition number. It measures the multicollinearity in your model. If you find higher the number, along with the condition number, you have potential multicollinearity issues. Multicollinearity தெரியும் இல்லையா? So the independent variable itself having their correlation. Independent variables should not have correlation amongst themselves. Independent and dependent variables should have correlation. Independent variable should not have correlation between themselves or amongst themselves. That is what it tells us. Log likelihood, yeah, log likelihood, as I told you, right? So this is also another measure. It tells us how well the model fits the data based on the likelihood function. That likelihood function, I'll explain it as part of logistic regression. Don't worry. Yeah, F statistics, I told, no, this is the F statistics is helpful to test the overall significance of your model. So what it does is it helps us to assess whether at least one independent variable has a non-zero coefficient. At least one independent variable has non-zero coefficient, or overall how well my model performs. With the probability of F statistics, we can decide how well my model performs with the given all independent variables. Got it, guys? Any questions? Okay, next one is I just